Hi, in this video, I'll be talking about how Google Vertex AI simplifies machine learning and the use case is movie rating prediction. So, in today's fast paced world, businesses of all sizes are looking to harness the power of artificial intelligence to gain a competitive edge. However, managing the entire AI workflow from data sets to deployment can be daunting, especially when teams consist of individuals with varying levels of machine learning expertise. This is where Google Vertex AI comes in. It's a powerful platform designed to address the many components of the AI workflow, making it easier for all team members to collaborate and work together effectively. Once you have defined your prediction task, the Vertex AI dashboard consists of these sections to help you ingest data, analyze data, transform data, train a model, evaluate the model, and deploy it. In this video, I would illustrate how to use Vertex AI for movie rating prediction. We'll first create a movie score prediction model using Vertex AI AutoML and the data stored in BigQuery. Then we would have the deploy model endpoint triggered from Google Cloud Functions. First step is the requirements. So in the Google Cloud Console, you need to select or create a Google Cloud project. Then make sure that the billing is enabled for your cloud project. If a billing account is linked, the billing overview page will look like this. If it's not linked, you would get a note saying this project has no billing account. So you would need to verify if your billing is enabled. Next, open the BigQuery and enable the API. This helps complete tasks like running queries, loading data, and even creating and training machine learning models. Then you want to activate your Cloud Shell and run these commands to confirm that G-Cloud knows about your project. Step 2 is preparing the training data. Preparing training data is crucial in ensuring the accuracy and effectiveness of machine learning models. Properly labeled and well-structured data can help models learn better and generalize, leading to more accurate predictions and insights. For this demonstration, the assumption is that the data is already prepared. Some of the features of the data are movie name, ratings, the genre, the year it was released, and the writer. Step 3 is creating and loading the dataset. The first thing you want to do is clone the repo from the GitHub page that was shown earlier into your CloudShare terminal. Then in your BigQuery UI, you want to click on the three dots next to the star to create the dataset. Then give a name for your dataset. This becomes the dataset ID, which you would need in order to refer to like the model, the dataset or the CSV file. Then choose a region and then click create dataset. In your BigQuery UI, this is where you see the dataset ID under your project ID. Use the BQ load command to load the CSV file into your BigQuery table. You should see the loaded file under your dataset. You can query the dataset using the BQ command, or you can use the BigQuery Web UI, which gives more visual information. Here, I'm going to increase number of movies shown to 10. And then I'm going to also add another column, which will be the year the movie was released. And then I'm going to look at the JSON file, some execution details, and the execution graph. Step 4 is using the BigQuery data in Vertex AI AutoML. Go to Vertex AI, you can search for it at the top tab, and then you need to enable the Vertex AI APIs that are relevant to the project. Expand the data tab in the tool sections to the left, then click on datasets and create the dataset. Type a name for your dataset and then create the tabular data type because of the type of file that we have. We are doing a movie rating prediction task, so we're going to choose regression/classification. Then select the table which we created earlier from BigQuery by just specifying the path and click continue. And once the data is created, once the data set is created, you should be able to analyze the page here and then click on train new model. We're going to click on other. Leave the objective as classification and select AutoML. Once we continue on to the next page, we can choose to export the test dataset to BigQuery. But the important thing here is that the target column is the score, which is what we're trying to predict for. Next, you can also select any advanced training options and the hours you want to train for. I didn't choose that because I wanted to see how long it would just take it to train. I chose a budget of one maximum node, which would cost about $21.25 for that one node hour. And the training cost of the model would not exceed this budget. Then click Start Training to begin training your new model. After 30 minutes, I looked at it to see how it was doing. Then I searched again for like about 1 hour, 58 minutes. It was still running. And finally, it finished training at 2 hours, 5 minutes. This was a long time for just like a demo. Then you can view and evaluate the training data here. I'm just sliding through different confidence thresholds to see how the curves sort of change. And I really like the fact that all the labels are given some information about what exactly they are, which would help with explainability for people of different skill sets and different levels of data science knowledge. In addition to these curves, there's also the confusion matrix for different confidence thresholds. And I really appreciate that they put this feature importance thing that tells you how much each feature impacted the training. And this was expressed using the sampled Shapely method. Then you can deploy and test the model with your API endpoint. First, create like your endpoint name, then just choose standard. Then here, the most important thing just for this demo is clicking on the explainability option, which would tell you more about the model when you're testing. Then you can configure your model monitoring. I like the fact that it kind of gives you the options to see if there's any training serving skew or if there's a prediction drift over time with your model. Then you can start deploying the model. Once it's deployed, you can test it. I'm going to first test on one of my favorite movies of all time, which is The Greatest Showman, just to see how good the prediction is. Online, I saw that average like the ratings were pretty high, so I'm like, kind of expecting that the prediction result gives it like a bit like of a highly weighted value. From checking different labels and seeing the confidence score associated with different labels, I think 8 had the highest confidence score at about like 0.49. And then I found another like random movie that's like had like really bad ratings. And I tried to see what it would predict the labels for, and I think 7 was the highest that it gave it, which to me was a bit off. Then step 5 is using the Java Cloud function to trigger ML invocation. So remember how we have that endpoint and all the other details for the machine learning model. Now we're going to use all of that here. So cloud functions help you run bits of your code locally or in the cloud without provisioning or managing different servers. So here I just copied the .java file from the GitHub repo, and then I'm going to change certain things inside the file, like including my specific project ID, my endpoint ID, and my location. Then I'm also going to change the XML file, the same file that was like in the GitHub repo. The only thing which I don't show on here is deleting the parts for MongoDB. Then you finally get the URL that you can use as like your endpoint. So yes, that's it. That's just a short overview of like how to do predictions using one platform and honestly making it as seamless as possible, but also like kind of quick and easy. So what are some of the strengths? It helps you accelerate models to production. Data scientists of various skill levels can move faster with purpose-built tools for training, tuning, and deploying models. The second thing is that there are a lot of pre-built models and tools which would really help with different use cases like image recognition, natural language processing, and more. And the last strength is scalability. It's built on top of Google Cloud, which provides unparalleled scalability and reliability for handling large-scale machine learning workloads. So, what are some of the limitations? The first one is the cost. Vertex AI can be expensive for projects with large data sets and complex ML projects. There's a lot of different things that you might need to like pay for based on like your usage. Just for the tabular data, it's about $21 per hour, like we saw before. So the cost can rack up really quickly. And then the second one is that there's limited support for non-Google Cloud platforms. It's designed to work with other Google Cloud platform services, which means that businesses may face compatibility issues when integrating non-Google Cloud platforms. And the last thing is limited flexibility. It's a fully managed platform, which means that businesses may not have as much control over their ML processes as they would with a self-hosted solution. So that's it. Like we've kind of gone through all the ups and downs, all the pros, all the cons, the examples of how to pretty much use Vertex AI. So thank you so much for watching. If you enjoyed this video, be sure to give it a thumbs up and subscribe to my channel for more content like this. And don't forget to hit the bell. Don't forget to hit the notification bell to stay up to date with my latest uploads. And if you do try Google Vertex AI, or if you use it on a frequent basis, I would love to hear from you. Thank you.